Welcome back to the Poly Math Teacher. So we are moving into solving by factoring. So make sure you've watched that last video probably twice and just done a lot of practice and you are solid on your factoring because this step assumes that you know how to factor pretty slickly. So make sure you're pausing this video and actually asking your questions. Am I getting this? Don't just keep writing it and copying it. But if you don't get it, put a sticky note down. Ask your teacher next class and say, hey, can you explain this? Because I'm confused on blah, blah, blah. Because the more you ask questions and advocate for yourself, the better you will learn and understand, remember, and because we learn what we ask questions on that actually matters to us. But then also, the better your problem-solving skills will be and just the more success you'll have in anything in life, whether it's school or your job or whatever you want to do. Anyway, so we are factoring, but we're now solving using that factoring skill. So we are moved on to solving. So I'm going to leave the comprehension questions up here now instead of at the end because I'll probably forget like I did last time. Make sure you are thinking about creating a brochure or a blog of how you would factor, because if you know how you factor, then you know how you will solve. So then also choose your adventure flowchart. How are you going to solve an equation? We already know how to graph and solve it. We know the square root property and solving it. Today we're working on factoring, and then next class we will work on quadratic formula, which will work every single time, but it's also kind of a pain because it's really long. So your other tools are a lot quicker, but sometimes you gotta go with the quadratic formula. So make sure you're doing that. Table of contents. We got 2 notes left, and then we're done with Algebra 1. Okay, so page 51. And then I'm going to have to put something else in this notebook. Okay, so we are going to have 3 circles at the top with steps, and then well, it's kind of steps. It's the logic process. Then we'll have steps, and then we'll do 2 examples. So that's where we're headed. That's where we're headed. So we need 3 circles. Woo! 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 You could make this a 3T chart if you wanted, but I figured circles looked cooler. So we have done this before. So if I gave you x plus 5 equals 7, could you solve this? So we eliminate the 5. We get x equals 2, hunky-dory. We could even do some fractions. We add the 2, divide by 3, so x equals 2/3. I sloughed off on the steps that it could fit in the circle. But if you want to add more steps, you may not want circles, unless that annoys you. Okay, so we've solved before, and we just learned how to factor. So we can factor by using the GCF method and taking out a greatest common factor. So sometimes, like if you have 3x squared plus 6x plus 9, I have no idea if this is really good factoring, if it's factorable or not, but 3, 6, and 9 all have a 3 in common. So you could actually have that come out, and then if this was a -3, let's make that a -9. Now we could factor that further, and we can say this is 3x plus 3x minus 1. And we could factor it farther by using grouping or logic. So I just did logic here. I didn't have to use grouping. I did the logic inside my head. So to me, I like logic, but grouping will always work. So if you are stuck and you're just like, I don't know what to do, stick with the grouping, totally fine. But this used GCF to get to smaller coefficients for the A, B, and C, and then I could do logic a lot quicker. Logic with this first one would have taken me a lot more time. Okay, and now we are going to introduce the new thing called the zero product property. Now, common sense already tells us this. It's just hasn't been given a name yet in life. So if I have 2 numbers that are multiplied, so I don't know what these numbers are, that's why they're variables, but I know if I multiply them, I get 0. So that tells me that x could be 0. If x is 0, doesn't matter what y is, boom, it's going to get me 0. Or y could be 0. Again, if y is 0, x could be anything, and boom, I get 0. So this is a zero product property, and because it happens when equations are equal to 0, hence specifically factors are equal to 0, then I can solve anything that has been factored. So our steps that we are going to follow in our 2 examples is, or are, so first we're going to get into standard form, and now this is going to be equation standard form. So it is going to be an ax squared plus bx plus c equals 0. Since we are solving, we need an equation, so there is an equal sign, so it must equal 0. So somehow get it, so that is a 0 on one of the sides. Then we are going to factor the expression part, so the ax squared plus bx plus c, so that's the non-zero part. That's our factor. And then our third step is to apply the zero product property, which is that guy. All right, so those are steps that we are following. You already know this one. You already know how to do this one. And you already knew this, you just didn't have it labeled in your head yet. So we're now hitting my camera. So now we're going to do 2 examples. Example 1 is going to be x squared plus 18 equals, we're doing 3 examples. So I'm going to do this one, I guess, first. Example 2 is going to be x squared plus 11x plus 28 equals 0. I added examples to my work. So we're going to do 3 examples. 2x squared equals negative 5x. Okay, there we go. So I'm actually going to start with example 2 first, just because this is already set up equal to 0, and then we'll figure out example 1 and 3 later. So for example 2, it's already equal to 0, so step 1's already done. Now I need to factor it. So I'm going to be using, I'll do grouping just so you can see grouping in action, but this one's pretty obvious to me for a logic standpoint. So if you know logic, try it on your own. So from a grouping standpoint, AC is going to be 28, B is going to be 11. Pause here. What 2 numbers multiply to make 28 but add to make 11? So those 2 numbers are 4 and 7. I'm going to drop the equal 0 until I'm done factoring, just so I don't have to write it. There's my first group, so they have x in common. Second group has 7 in common. Notice how my quantities inside are both x plus 4. So if those equal, then I know I'm good. So now I'm going to get a factored form of x plus 4 multiplied by x plus 7 equals 0. I'm bringing down that equals 0. Now, I have 2 factors that are multiplied together that equal 0. That means that I can solve x plus 4 equals 0 and x plus 7 equals 0. And I know that that means my x values will be negative 4 and negative 7 because I know how to solve equations. So that means my x-intercepts when I graph this function, so if f of x equals x squared plus 11x plus 28, my x-intercepts will be hitting at negative 4 on the x-axis and at negative 7 on the x-axis. So, yay! That was it. All right. Example 1, I need to make sure this is step 1 already done. So I'm going to eliminate the 9x on the right hand side, which means it's going to become a negative 9x on my left hand side equals 0. So I eliminated that 9x by subtracting it to both sides. I've factored by grouping over here. I'm going to factor by logic over here. So I need to multiply to 18 and add to make a negative 9. So this is going to be x minus 3 x minus 6 equals 0. So that means I have 2 equations to solve. I have x minus 3 equals 0, x minus 6 equals 0, so x equals 3 and 6. It's not always this nice with whole numbers. Sometimes you will get fractions, so be prepared for a factor like 3x minus 2, where your x-intercept will be at a fraction. So that is possible. This is not always nice whole numbers. We are just looking at examples and notes. And maybe we'll even get under 10 minutes. Woohoo! Okay, so on this one, I'm going to eliminate this 5x from the right-hand side. And so when I do that, I'm going to end up with 2x squared plus 5x, but I don't see any c, all right? So I am going to actually do this a different way. So I could have plus 0 equals 0. That would work. Now I could factor this by grouping because I have a C. I could do A times C. I have a B. I could figure that out. Totally fine if you wanted to do that. If you did, it would end up AC is 0, B is 5. So two numbers that multiply to 0, but then add to 5 would be 0 and 5. Okay, so I'm going to have 2x squared plus, and this is where it gets tricky sometimes with that 0 in there. I think, yeah, because I have to put the 0x first, otherwise it'd be the same exact thing as before. So that means they have x in common, so you get 2x plus 0 plus 5x plus 0, but how do I get the 2 in there? I don't remember how grouping works for this one. You'll have to practice them more on your own to figure it out. So I'm just going to scratch that. But it's a challenge. If you want to try to figure it out, figure it out. It's simpler to look at it from this standpoint. So again, it's still in standard form. It has to be my quadratic equals 0. But what's the GCF of these two? It's x. And then I get 2x plus 5 equals 0. So my goal over here was, oh, this should have been 2x. There we go. And that should have been there. Okay, that would have fixed it. So if I had 2x, x plus 0 plus 5, x plus 0, that would work. Now this x plus 0 factor is the same as this just x by itself. So not to confuse you more, but you could group it like this if you wanted, or you could group it, factor it like this. And that means my two equations I'm solving are these two, because those are my two factors being multiplied by each other and equaling 0. So x equals 0, and then x equals negative 5 halves. So I get two solutions there. All right, that should be good. We're just under 12 minutes, and I've already gone over your expectations, so you should be good. All right, thank you for watching, and have a great day. One more lesson. We can do it. Bye.